Chapters 10 and 11, continuing our discussion on the gases. In the previous section, we talked about properties of gas laws. We talked about the characteristics that they exhibit as far as at the molecular level, as well as some of the physical quantities and physical and chemical observations that we can make of these gases. What I want to talk about now are a few of the gas laws that we're going to be using to discuss some of these properties that we talked about, like pressure, temperature, and volume, and all that kind of stuff, right? And this is nothing new. You've done this in physical science or either in 6th grade science in middle school. But the first law I want to talk about is Boyle's law. Boyle's law. Boyle's law allows us to relate pressure and volume. Okay? As pressure increases, volume decreases. Think about putting pressure on an aluminum can. Is the volume going to increase or decrease? The pressure and volume of a gas are inversely related. That means as one goes up, the other one comes down at a constant mass and temperature. So temperature must stay the same. So if we're working problems and we say that the temperature must stay the same, or the temperature stays the same, then we know that we can apply Boyle's law. So Boyle's law equates pressure and volume is equal to some constant. Okay, is equal to some constant. That value stays the same. As pressure increases, volume will decrease, and you still have that same measurement, constant measurement. Charles' law. Charles' law makes a relationship between volume and temperature. Charles says that as temperature increases, volume will also increase. Okay? As temperature increases, volume will also increase. Volume will also increase. Alright, the absolute temperature. Remember, we must use Kelvin measurements when talking about, when dealing with gases, because that relates our energy in our particles, our molecules, to our calculations of a gas are directly related. Now, they must have a constant mass, and we're going to talk about changing the mass up here in a few, in about a section. And they must have a constant pressure. So as you increase temperature, volume must also increase. Think about if you leave a canned Coke in your vehicle, and it's hot outside. You know, it gets in 100-degree weather here in Louisiana. As the temperature increases on that can that's left in your car, the volume is going to also increase. And when the volume increases beyond that, what can be held in that sealed can, it's going to explode and put Coke all over your vehicle. Gay-Lussac's law, okay, relates temperature and pressure. He says that as temperature increases, pressure also increases. As temperature increases, pressure also increases. So pressure and temperature of a gas are directly related at constant mass and volume. This is kind of how, and this just makes sense. As you're going from one phase of matter, being the liquid form, to another phase of matter, as you're increasing temperature, the pressure of that's going to increase because your volume, because your molecules are getting further and further apart. Now, in order for Gay-Lussac's law to be correct, you must have a constant mass and a constant volume. This is like a sealed container. Back to that Coke can we were talking about in your car that's getting hot. There's a great deal of pressure on that. You may have noticed, if you've ever had one explode, the top of it will actually come and poke out just a little bit right before it explodes. Or you may have caught it before it exploded and it has that top pushed out. So the pressure is getting great in there. You may feel it kind of tight on the outside. All right, and the combined gas law. The combined gas law takes into account Boyle's law, Charles' law, and Gay-Lussac's law, and combines it into one simple law. Pressure times volume divided by temperature is going to stay constant. All right, it's going to stay constant. Now, typically what we do in chemistry is we compare conditions. Remember, we study the change that matter undergoes in chemistry. So we like to see what changes we can observe, and we like to quantify those, and this is one way that we can quantify. We typically talk about what's happening initially and compare that to what's happened after, or finally, or what's happened after the change has occurred. All right? Now, an easy way to remember this, you can remember P1 times V1 divided by T1 is equal to P2 times V2 divided by T2. But I like to remember PVT equals PVT, and you just have to remember that 1, 1, 2, 2, 2, 1 subscripts. PVT equals PVT. Either way you want to memorize it is fine with me. This way is easier to me, and this is the way I actually look at it on our problem sets, but this may be easier for you to memorize. I know this is how they do it in physical science.